Venkatesh sir,
Sir?
now we start, sir.
Okay, so okay, sir. I will start. So, good morning to all the participants. So, on behalf of our management, principal, vice principal, HOD, and the faculty members from Department of Mechanical Engineering, I welcome you all for this 12-day short-term course on finite element analysis. So, today our topic is second order two-dimensional equations involving scalar variable functions and variational formulation, finite element formulation, and triangular elements. So the session is handled by Mr. R. Prabhakaran, Assistant Professor, Department of Mechanical Engineering, Ramco Institute of Technology, Rajapalayam. He completed a Bachelor of Engineering in Mechanical Engineering domain at St. Joseph College of Engineering, Chennai in the year of 2014 and completed his ME in CAD/CAM at Sri Ramanujan Engineering College, Kolapakam in the year of 2016. In 2017 to till now, he working as an assistant professor at Ramco Institute of Technology, Rajapalayam. His area of interest is additive manufacturing, welding technology, and CAD/CAM. He published more than 3 international journals and he attended more than 7 international conferences at reputed institutions. Also, he conducted many programs and seminars and workshops through RIT Mechanical CAD Center. Also, he filed one patent in the topic of manually operated geared stretcher for effortless shift of wounded or injured patient to bed in 2019. Also, he active member of SAE and ISTA. Also, he many times produced 100% result in the subject of ME6019 non-destructive testing and materials. In the year of 2017 to till now, he producing 100% result. Also, he coordinated the bicycle competitions under the name of RIT patents conducted by SA India Southern Zone in the year of 2019 to till now. So now the session is hand over to the Mr. R. Prabharan, sir. So I warm welcome you, sir.
Okay. Thank you for this introduction, sir.
And thank you, sir.
Okay. Good morning, everyone. On behalf of Ramco Institute of Technology, Department of Mechanical Engineering, RIT MechCAD Center, and IEA, I warm welcome you all for this 6th day of short-term course on finite element analysis. So before starting, just I remember, so this is the 6th day. So last 5 days, we have covered so many things. As mechanical finite element analysis point of view, we have covered first unit and 50% of syllabus covered in the second unit. Today, I'm going to start with the third unit introduction topic, and we will continue our journey. So this is my third lecture in the series. Last 2 lectures, I gave the lecture on the topic variational formulation and a shape function for one-dimensional element. In continuation, I'm going to handle scalar variable problems in this topic. Okay, so already we come across in this session, especially for solving problems. Solving problems, formulas are very essential. So definitely we need to solve shape function for that two-dimensional triangular element and a rectangular element. This is the main motto of this lecture. So I hope definitely it may be useful. So the scalar quantity is that magnitude, but no direction. In vector quantity, we can define simply magnitude and direction. So without explanation, just this tabular column give all the data instead of wasting the time. So we can simply say the time mass volume area. So we can say simple the real numbers, the 20 minutes, 30 kilogram, volume is the somewhat meter cube, and area is the somewhat meter square. So it does not need any direction. So we can simply call it as the scalar quantity. For vector example, this is the vector example. I'm going to take it as that acceleration, wind velocity, and weight. So we want to define magnitude as well as the direction. So 9.8, it is the acceleration due to gravity. So definitely the vertical downward. So wind speed from which side to which side, and velocity and weight vertically downward. If we have to consider the self height, so vertically downward. From that you can easily define the scalar and the vector variables. Our FEA also, we have a specific topic for two-dimensional scalar variable problem for the third unit, and the two-dimensional vector variable problem as the fourth unit. So, in my point of view, compared to all 5 units, the third unit is very, we can understand easily in technical way as well as the concept and the shortcut way, because of we can easily understand the concept through our mathematical concepts. So this is the simple introduction for the scalar vector quantity. This is the example: distance, speed, mass, energy, density, power, length, area, volume, time, temperature, work. So every quantity just we can define with the magnitude, but this is the quantity we need to explain magnitude and direction. So this is the example. This is very familiar. So we can now we can move with the topic. So next, save function. So already we have discussed. Already I taught only one-dimensional save function. So what is save function? Why we are using save function? What is the save function is called also called interpolation function. So how the name came? So like that we have discussed in the previous classes. So just I will recall what is the save function with that with some example. For example, I'm going to take one-dimensional element for understanding easily the save function. Already we have discussed. Just within 1 minute or 30 seconds, I will remember. I'm going to consider as my one-dimensional bar element here. So this is for the my first nodal point. This is for the second nodal point. So one dimension, if I'm here, I'm going to discuss about the two-dimensional. Just I recall with the one-dimensional, then only we can understand very deep manner. So here, two node, we have a 2 degree of freedom. As well as if I'm going to assume, so temperature is somewhat 10 degree. So otherwise, I'm going to temperature here, the second nodal point, 30 degree. So the total length may be, I'm going to take it as so 100. So this is the, for example, for the one-dimensional problem. Suppose I want to find out the temperature at the distance 50. I'm going to find out the temperature at the distance 50. So what way we can find out? So definitely everybody can solve this problem without using any formulas. Simply the aptitude manner we can solve the problem. So that so we can simply technical way we can tell that is for the interpolation function. So this is the way the interpolation name came for the save function. The same thing I'm going to follow for our one-dimensional and two-dimensional geometry. So save function also define the shape of the geometry. So from that equation, simply we can understand what is the shape, whether it is the quadratic shape or linear shape. From the function, we can easily understand. So okay, we will discuss with the concept. So this is the mathematical expression used for the finding the value inside the element by means of nodal values. So I taught just a one-dimensional element example. So we will go with that. So if you take a one-dimensional example, pi of x comma y equal to n1 x comma y, n2 xy, and pi 2. This is the pi 2 is the field variable. For this the scalar variable problem, I'm going to take it as the scalar quantity as my field variable. For example, I'm going to take it as the temperature. So T of x comma y equal to n1 t1 xy, n2 t2 xy. Like that we can write it as for one-dimensional element. If I'm going to take it as the two-dimensional element, for example, I'm going to take it as two-dimensional element as my triangular element. So triangular element have a 3 nodes, 1, 2, 3. So definitely we need to consider as the, so here 3 nodal, I mean, so for per element, if I consider the 2 degree of freedom, definitely it may be the 6 degree of freedom. So you don't confuse, just I will start with the scratch we will go deep in later slide. So you can consider as a triangular element. For every nodal, just I'm going to consider as the CST. I will explain what is the CST, LST, QST in the last lecture. So here I'm going to consider the 2 degree of freedom, 3 nodal, 6 degree of freedom. So from that we can define the CST element. Okay. So 3 nodal, I'm going to define N1 and N2 and N3 as my interpolation function, shape function. Okay. This is my field variable. So this is for the sum of the character. I hope you can understand very clearly. This is the very fundamental for the FEA. So shape function characteristic, this is that already we have proved unit value at its own nodal point, zero value at other nodal point. Sum of the shape function is equal to 1. Just we will solve triangular element, 2D triangular element shape function and 2D rectangular element shape function. Definitely we can prove these things equal to 1. And the same type as original interpolation equation within the polynomial is the same type. This is also simplest thing. Okay. So next we are going to take it as, so now I'm going to consider as one triangular element. Okay, I'm going to consider as the triangular element because of this is the concept I'm going to solve 2-dimensional triangular element. Okay, so here this is for the, you don't consider about degree of freedom, just I will explain later. So here the triangular element we have a 3 node, just this is for the, so first node, this is for the second node, and this is for the third node. Okay, so every time just we need to consider so anti-clockwise direction. Okay, as per that derivation it may be very easy. Okay, just I am going to solve, I'm going to, just I have taken for anti-clockwise direction. So 1 2 3 nodal I have defined in the anti-clockwise direction manner. Okay, so first node, that is for the x1 y1, second node x2 y2, third node x3 y3. Okay, so now I'm going to use area coordinate method. So that is the way I'm going to solve the shape function. So I'm going to consider this triangular portion into the 3 portion. So this is the first one, the opposite, this is the first node, the opposite triangular is that area of that first element. So the second node, this is the second node, the opposite element as the area 2 element. So this is the third one, this is I'm going to consider as the third one is the area of the third element. Okay, just I have split up 3 element. Okay, this is the A1, A2, A3. Okay, so just we can simply call it as, so shape function for triangular element are just area coordinate method. Okay, this is the simplest way. This area coordinate method is not available our normal textbook. So okay, just you can watch get deeply. Definitely it may be very useful, and this is very easy and we can understand the very technical way. So next, so I'm going to consider as this is for the 2-dimensional. So 2-dimensional cases, 2-dimensional, 3-dimensional cases, we can take it as our polynomial function from that Pascal triangle. So I'm going to consider as, so here this is for the pi 1 equal to a0 plus a1 x1 plus a2 y1. Here we have a 3 nodal. So 3 nodal I'm going to consider as, so pi 1, pi 2, pi 3. So this is the a0, a1, x1, a2, y1. So second a0 plus a1, x2 plus a2, y2. So third a0, a1, x3 plus a2, y3. So finally my intention I want to consider as a matrix form. So definitely we can change this one is to matrix form. I'm going to write it as, so matrix way. This is the final matrix. Okay, so we can as per the rule shape function in area coordinate method we can write, so n1 is, so determinant of a1 by determinant of a, so n2 as determinant of a2 by determinant of a, so n3 is equal to determinant of a3 by a. So this is the simple, we can easily understand how it may arrive. So if you have to, this is for the whole triangle, so consider as the a area xy. So here I'm going to consider as I'm going to consider as the one triangle A1. Just I'm going to consider as the particular A1. So likewise we can consider as the A2 and A3. So 3 nodal I'm going to consider as the N1, N2, N3. So like that I have just wrote A1 by A, A2 by A, and A3 by A. Okay. So now I'm going to convert this equation into matrix form. I'm going to rewrite this like, So this is for that. So my field variable pi1, pi2, pi3 is equal to, so I'm going to write it just a global matrix and a connectivity matrix. So this is for the 1, 1, 1, x1, x2, x3, and y1, y2, y3, a0, a1, a2. So this is for the 3 cross 3, and this is for the 3 cross 1. Finally, we will arrive 3 row and 1 column. This is for the 3 row and 1 column. This is the way we can convert our equation into the matrix form. Okay, so now I'm going to consider just simply we can write it as area of the triangle. We can write it as half into pH. Okay, so here all the points are coordinate. So like that, I'm going to so take it as area formulas of 1, 1, 1. So that this is for the first nodal x1, y1, x2, y2, and x3, y3. We can, this is for the area for the whole triangular element. This is for the area for the whole triangular element. Okay, so now I'm going to consider as the individual triangular. So I'm going to consider this is the A, and next we can write it as A1 as, so 1, 1, 1, xy, x2, y2, and x3, y3. 1. So the opposite is the, so 2, 3. Okay, just you can remember this is the 1. So I'm going to take it as the counterclockwise direction. 2 and 3, this is the central point. Okay, so from that I can write it as, so A1 equal to of 1 xy and 1 x2 y2 and 1 x3 y3. Okay, next, so I'm going to write the same way. I'm going to write, so A2 and A3 value. So A2, the opposite triangle x3 y3 and x1 y1. So I'm going to take it as the same way, area 3 as of 1 xy, and this is the third element. I'm going to take it as, so first and second nodal point. Okay, so this is the way I can write. So area 1 and area 2, area 3, the whole triangle area. So now I'm going to substitute all the value in our shape function. So here n1 equal to determinant of a1 by determinant of a. So n2, n3, likewise I'm going to substitute. Finally, we will check our property, whether it is sum of shape function is 1 or not. So like that, we can check our shape function. Okay, so node 1, so this is the simplest formula, n1 by a1 by determinant of a1 by a. So I can write it as my formula a1, the 2 and 3 node. So just I have written like that, and area, the overall triangle formula, just I have taken the determinant value. So finally the 1 by 2, the 1 by 2 will cancel. So finally, so this matrix, I mean the determinant value may be achieved like that. Okay, so I'm going to follow the same for nodal 2 and nodal 3. So I'm going to consider the node 2. So determinant of a2 by determinant of a. So determinant of a2, second, this is at the second triangular element. The opposite one is the 3 and 1. I will consider the thing a2. So divided by the whole triangle. So finally I have taken, so determinant values. So we have achieved this like n2. Okay, finally the same way I'm going to write it for the nodal 3. So n3 equal to a3 by a. So n3 equal to a3 by a. So a3 I'm going to consider the first and second element, second coordinate. So this is the area for the whole triangle. So finally, just I have achieved n3 value. Okay, so I'm going to now, this is the way, just we have achieved n1, n2 and n3. Okay, so this is simply we can understand from the concept. We don't want to bygate anything. As a student point of view also, just to understand the concept. From that, what is the just from we can solve shape function in the global coordinate, local coordinate. So anyway, this is the simplest way, area coordinate method for getting shape function. So I'm going to check our shape functions are valid or not. So I have found n1, n2, n3. So I'm going to add the three things. So n1 plus n2 plus n3. So definitely we will be achieve 1 because of the denominator value is common for all. So x2, x3, x2, x3, x3, and 3, 2, 3, 2, 3, 2 here also the same, everything same. Finally, we have take and just we have ordered all values. So finally, we will be get that 1. This is the final answer. So whenever solving problem, just we can simply remember this is the n1, n2, n3 for the so two-dimensional so triangular element. Okay, so we are discussing about scalar variable problem. So definitely without shape function we can solve the problems. So this is the way we can understand how the rectangular element. I'm going to analyze the rectangular element. Okay, so this is also two-dimensional. So I'm going to solve shape function for the rectangular element using local coordinate method. Okay, so this is for the bilinear quadrilateral element. Because of this is the rectangular, the opposite sides are same. Okay, the breadth is equal and here the height is equal. So we can simply call it as bilinear quadrilateral element. Okay, so here I'm going to solve shape function by using the local coordinate method. Okay, okay, right. So simply I'm going to consider this is my triangular element. So here the first node, second node. So this is my third node. This is my fourth node. Okay, so I'm going to consider this is my breadth and this is my height. This is my breadth and height. Okay, so here I'm going to give some coordinate. I'm going to assign that local coordinate. So this is for that point 0, 0. So I'm going to say this is for the, so this is the breadth b, 0, and this is the third b, h, and the fourth one is the 0. This is the height h. This is the way we can assign the coordinate value. Okay, so already we have discussed what is the one-dimensional our polynomial equation. What is the two-dimensional polynomial equation? Here rectangular element, again we want to rewrite our polynomial equation because of in one-dimensional element we have a two node. Is it the first and second node? I mean starting and ending. In triangular element we have a three nodal triangular element. So rectangular element we have a four nodal. So definitely we want to consider. So a1 plus a2x plus a3y plus a4xy. This is the way we can rewrite our equation for a rectangular element. Okay, now I am going to apply my boundary conditions. Now I am going to apply for boundary condition. So this is my first node. So this is the first node. I am going to consider 0, 0, 0, 0. Displacement, I am going to take it as the u equal to u1. Displacement u equal to u1. The second node I am going to consider b, 0, u. Displacement is equal to u2. So third node, node 3, I am going to consider. This is my node 3. So b, h. So u equal to u3. And the fourth node, this is for the 0, h. That is for the u equal to u4. This is the way I am going to apply my boundary condition in the equation. Okay, just I'm going to apply that. So boundary condition 1 in equation 1. So my boundary condition 1. So this is my boundary condition 1. So xy, I mean 0, 0, u equal to u1. I'm going to apply the boundary condition here. So u will be changes u1. So instead of x and y, I'm going to substitute 0, 0. So definitely your value will be u1 equal to a1. So like that I have written u1 equal to a1. Second, I'm going to apply my boundary condition 2. So this is my second coordinate b, 0. I'm going to apply u equal to u2 in that equation. So u will be converted into u2. So instead of y, I'm going to substitute 0. So a4 value will be 0. A3 value will be 0. So x, I'm going to substitute b. So u2 equal to a1 plus a2b. So this is the way we have achieved the second equation. From that, so finally I'm going to find, my intention is find out a1, a2, a3, a4. Okay, so because of your unknown in that polynomial equation is a1, a2, a3, a4. If you found a1, a2, a3, a4, so our shape function will be arrive easily. So that's why we are discussing applying boundary condition. We have derived some mathematical concepts. Okay, now I am going to apply the boundary condition 3. So instead of applying boundary condition, you will be confused because of we have a to x and y we have a value. Just wait, I will discuss after fourth boundary condition. Okay, so next our fourth boundary condition. So I'm going to apply my fourth boundary condition to the equation. So 1, 2, and again I'm going to take it as the anticlockwise direction. So for easily solve our derivation, you can take it as anticlockwise direction. Okay, so the fourth one 0, h. Okay, so here wherever substitute x value, you can substitute 0, and y we can substitute h value. So here, so x value will be 0. The a4, a2 term will be cancelled. So a3 here h. So next, so U4 equal to, I mean, instead of U, you have to substitute U4. So U4 equal to A1 plus, so you can write it as A3H, like that. So our fourth boundary condition will be arrived. Okay, this is our fourth, I mean, fourth boundary condition. So U4 A1 plus A3H. Okay, so U4 minus, so I'm going to substitute as, so A1 is U1. So U1 by H equal to A3, because of we already know. So A1 equal to U1. Okay, so like that I have substituted here A1 equal to U1. So U4 minus U1 is equal to A3. Now we can concentrate. So boundary condition 3. Okay, now we can concentrate boundary condition 3. So we have a the third boundary, we have a B and H as our coordinate value. So instead of X and Y, I'm going to substitute B and H. So U X comma Y. So I'm going to write it as U3 A1 plus A2B plus A3H plus A4BH. So this is the way just we got the equation. So here I'm going to rewrite something. Instead of A1, I'm going to substitute U1. So instead of A2, I can substitute U2 minus U1 by B. Okay, U1 by B. So like that I have written my equation. So finally, we don't know about A3 and A4 value. Now we got A4, I mean, this is the A3 value. So again, I'm going to substitute A3 here. A3 equal to U4 minus U1. This is the unknown A4. From the equation, finally, we can get the A4 equation. Okay, so this is for our A4. So finally, we got A1 and A2 and A3 and A4. We have obtained for A1, A2, A3, 4. So finally, we can substitute our value into, so our, I mean, equation U of X comma Y equal to A1 plus A2X plus A3Y, A4XY. Okay, so I'm going to write it as, instead of A1, I'm going to substitute U1. Instead of A2, I'm going to substitute something value, because of we have found everything. So here A1, A2. So here we have obtained A3 value and A4 value. I'm going to substitute all value here. So this is my final equation. Okay. So for our easy way, just I have take it as U1 as the common value. Okay. So here I'm going to take it as the common way. So finally we have obtained this like equation. Okay. So now it obtained finally. So U1 some value plus U2 some value plus U3 value and U4's value. So this may be given our shape function. So I can rewrite here. Simply we can write it as, so U of X comma Y equal to so this is, I can consider as my N1. Okay, so this is for the N1 U1. So I can consider as the same N2 U2 plus, so I'm going to consider as the, this is the our shape function N3 U3 plus, this is for the N4 and U4. Okay, this is for the N4 and U4. So instead of the shape function N1, N2, N3, N4, we can write some equation. Okay, this is the way finally we got result for the shape function. Okay, so definitely we can check whether these shape functions are whether it is my optimum or correct way. So definitely we will check the characteristics of shape function. Okay, so finally this is the N1, N2, N3, N4. So I'm going to check. So our sum of shape function value will be 0. I'm going to add all the values. So N1 plus N2 plus N3 plus N4. So this is the final equation. So after some calculation, so all the value will be cancelled. The numerator BH and the denominator BH. So definitely the BH value will be cancelled. Finally, we will get the 1. Okay. So this is the final. So definitely whenever solve the rectangular element, so N1, N2, N3, N4, we can directly taken from this shape function. This is the final value. Okay. So as of now, we have derived the two shape function. It is essential for solving problems in third unit. I mean 2-dimensional scalar variable problem. Okay. So one is the triangular element. Second one is the rectangular element. Okay. So now we can go with our problems. Definitely we may understand very clear. Okay, so rectangular way. So rectangular, just we can simply define N1 is the 1 minus x by b, 1 minus y by h. So again, I remember shape function, interpolation function. From that, we can find out all the value inside the element. Okay, that's why we are derive shape function. Whatever it is, and from second unit to fifth unit. So every topic have a shape function. From the shape function only, we can derive some we can identify the shape of the element and the interpolation function. This is the very essential thing for solving our stiffness value and the force vector and some every further solving all the concept. Okay, this is very essential concept and the fundamental thing. So finally, in rectangular element, we can simply written as 1 minus x by b, 1 minus y by h. The second thing, the x by b common 1 minus y by h. The third thing, the xy bh. This is for the third nodal. The fourth nodal I have taken as so y by h common, and this is for the 1 minus x by b. This is the simple way students may understand. Okay, because of the compared to all other subject, if a subject is somewhat difficult, it is not difficult. Definitely, we want to understand some mathematical concepts. Because of all the concepts behind of the mathematical modeling and the concepts. Okay, and also in GATE exam point of view, also it is not a syllabus because of it is very difficult. But in computer integrated manufacturing, this is the one of the syllabus for GATE examination. From that, some of the basic questions may come for the GATE examination and the PSU and the ESE examination. So students who are the GATE aspirants, just you understand the basic concept. What is the one-dimensional, two-dimensional, what is the three-dimensional, and what is the shape function, what is my nodal, what is my element, what is the non-linear, linear, what is my structural and non-structural problem. Okay, so in the previous some 2 years back, I have seen one of the two questions from that tangent and gate. So what is the serendipity element? What is that surface nodes? What are the, I mean, say, if you consider CST element, how many nodes, how many degree of freedom? So like that, simple questions may come in the GATE examination also. Just you should remember basic concept, then only we can attend all the objective question. Okay, so now I move on the topic. So this is the simple tricky. This is the very easiest thing. Students' point of view, just to clear cut, you may get clear cut idea about two-dimensional scalar variable problem. Just to understand the two things. One is the triangular element. Second one is the rectangular element. Okay. If you consider that a triangular element, you should remember the three nodal, rectangular element four nodal. So like that, we want to write the our shape function a1 plus a2x like that. Here we want to consider a1 plus a2x plus a3y. Next, if you consider the two-dimensional rectangular a1 plus a2x plus a3y a for xy. So like that, you should remember. Okay. So in many of the questions, whenever solving the problem, we should remember this is the key points. Okay. So sometimes they will give the coordinate point. We want to find out the temperature from the shape function because of this is a scalar variable problem. So we don't want to discuss about the displacement forces because of that it may be concept of the category for vector variable problem. But in my analytic point of view, the question may be come any in third, fourth, fifth unit. It may become any type of question. So you should understand the concept. Then only you can attempt very clear. Okay. So sometimes they will give the point. We need to find out the temperature using the shape function. Sometimes they will give the temperature region. From the temperature region, we want to find out the point. So I will explain one by one. Okay, just to understand the key point. So second thing, the key point. So just I have solved derivation using the anti-clockwise direction. Definitely you may consider the anti-clockwise direction. So and again you want to remember isosceles triangle concept and the geometrical rule for solving triangular rectangular element. Okay, so I will explain one by one. So next I'm going to approach if I want to approach the triangular element, just if I directly solve the problem means definitely you may get a doubt for how you got the formulas. So that's why we solved a derivation. Okay. So here I'm going to just revise the triangular element. So three nodal. So first, second, third node. So just I have taken anti-clockwise direction. So we can write it as the shape function as so t of x comma y equal to n1 t1 n2 t2 and n3 t3. just we have derived all those things. N1 means we know that. So because of just I have area coordinate method, I have split up into 3 triangle. We can write it as the shape function like that. So we know that area is the whole triangle. We can write it as the area formula, A1 formula. So area formula I have considered as the 3 nodal. A1 I have considered the 2 and 3 nodal. So on the A2, 3 and 1 and 1 and 2 for the third nodal. So like that I can substitute my value. So instead of I got the N1 into N3 formula, so directly you can consider this direct approach. Definitely it may be give some easiest way to solve the problem. So suppose this is that one of the concept. If they may give the temperature value and the 3 coordinate value, they may ask a particular point the temperature value, we can easily solve the problem. Sometimes they may give so temperature region as 50 degrees Celsius. For that particular temperature region, where particular temperature region where it may be crosses, like the question may become. So definitely we want to find out the points. So this is the 50 degree, for example. So this is the 50 degree region. Okay, this is the 50 degree region. So they may give 50 degree as a region. So they may be asked what is the point process. Okay, we want to find out the point XA, and XB, okay. So sometimes it may become like that also. So that time also you want to find out the particular 2 points. Okay, so depends upon our temperature value. So it may be changes. Okay, definitely we want to. This is a free reconstruction knowledge. So that is for the geometrical rule. What is that geometrical rule? Isosceles triangular concept. I will explain one by one. From that we can solve the problem very easy. Okay. So next up. So geometrical rule. This is the geometrical rule behind of that one-dimensional triangular element. Suppose I'm going to find out my XA OA value. Okay, I'm going to find out my XA and OA value. This is my XA OA. So how we can find out the value? So this is the way. So this is the geometrical rule, very helpful for solving and to find out XA OA XB YB value. Okay, so just again you should remember 1, 2, 3 anti-clockwise direction. I'm going to write my geometrical rule. Okay, so here this is the XB YB. I can write as so XB minus X2 divided by X3 minus X2 is equal to our known field variable. So temperature at that particular point minus T2 divided by T3 minus T2. Okay, so temperature means this is the known value because of they may give this is the temperature region, like that they may give this is for the known value, right? So again I remember, so XB minus X3 divided by X3 minus X2 is equal to temperature minus T2 divided by so T3 minus T2, like that we can write it the first geometrical rule. Again I want to travel the anti-clockwise direction. So just from that relation we know X3 X2 X2 value, X3 value, T3 T2 value and the temperature value. From that definitely you can find out your XB value. Okay, the geometrical rule is very important. Just watch keenly. So second thing, I want to find out YB value. The same way I'm going to write the geometrical rule. So YB minus Y2 divided by Y3 minus Y2 is equal to T minus T2 divided by T3 minus T2. Like that we can write down geometrical the second rule. So here we know every value Y3 Y2 value and T2 T3 value. So temperature also known value. From that we can find out your YB value. Okay, so this is the very easy rule for the first and the second coordinate. Again I want to travel that anti-clockwise direction 1, 2 and 3. So next I'm going to consider this is the way, this point XA YA point. So I'm going to write the geometrical rule as XA minus X3 divided by, so I'm going to take this YX1 minus this is for the X3. Okay, so the same thing I can write it as the temperature as temperature means T minus T3 divided by T1 minus T3. Okay, from that way you can find out your here X3 X1 temperature and this is the temperature region. Every value we know. From that we can find out your XA value. Okay, so I'm going to write it the same concept. I'm going to apply for the Y coordinate. So YA minus Y3 divided by Y1 minus Y3 is equal to T minus T3 divided by D1 minus T3. So here also we know that all value y3, y1 value and t3 and t1 value. So we can find out your YA value. T is the temperature region. We can easily find out your YA value. Okay. So this is the geometrical rule applied for your triangular element whenever we got the temperature region as a data. Okay. So next here I'm going to take it as rectangular element. Okay, whenever consider the rectangular element, so the same rule I'm going to apply for that. Okay, here also I'm going to take it as that anti-clockwise direction. So my point as, so this is my point. So n1, this is the x1, y1 first point, second point, third point, and the fourth point. So we know that simplest shape function because of the four node triangle rectangular element. So I can consider as n1 t1, n2 t2, and n3 t3, and n4 t4. Okay. So already we have derived the shape function. Finally, we got n1 is the 1 minus x by b 1 minus y by h. N2 is the some value x by b common and 1 minus y by h. N3 equal to x by b h, and n4 is the y by h 1 minus x by b. If we know that for temperature and for coordinate, we can find out the temperature at the central, I mean xy point. So in the particular point, what is the temperature? We can easily identify through the shape function and n1 into n3 n4. Suppose we got the temperature region as our data. So again, I want to use the geometrical rule. The same way, the same concept I'm going to apply here. Okay. So definitely, if it is the temperature region, it may be considered as 50 degrees Celsius or 60 degrees Celsius. Definitely, we want to consider XA and YA and XB and YB. Okay. So geometrical rule, that is the same concept. So here, this is my XA, YA anti-clockwise direction. I can write it as the same. So here this is xb, yb means better you can consider the first, this is the first equation without confusing, you can easily understand. So I'm going to consider this one. So xa minus x1. So here also, so I'm going to consider as the second point. This is the second point. So x2 minus x1 is equal to t minus t1. Again, next t2 minus t1. This is the way. So temperature t1, t2, temperature value x1, x2, everything the known value. From that, definitely you can find out your XA value. Now I'm going to apply, I'm going to find out my y coordinate. So I can write it as the same way. YA minus y1 divided by y2 minus y1 is equal to t minus t1 divided by t2 minus t1. Okay, the same way I can rewrite it as the equation. So from that, we know that all temperature value and the region temperature value. So this is the unknown value. We can definitely find out where the temperature is, the region crosses that particular point, we can easily find out. Okay. So again, I want to travel the anti-clockwise direction. So this is the next point. This is the unknown point. So I want to consider this is the anti-clockwise 1. So this is the 2, and this is the 3, and this is the 4. So from that I have found out this unknown. So next is the unknown xb, yb. So I can write it as the equation as xb minus x3 divided by x4 minus x3 is equal to t minus t3 divided by t4 minus t3. Okay. So from that the region value and all other value, from that we can find yb minus y3 divided by y4 minus y3 is equal to t minus t3 divided by t4 minus t3. From that, this is the everything, so known value. So from that you can find out your yb value. There's the same concept. So both the triangular as well as the rectangular element. So I'm going to apply for the same concept. So definitely you should remember the polynomial function. The polynomial function will be varying. Okay, depend upon the polynomial function. So we have obtained shape function. So it may be the final answer. Okay. So next, I'm going to consider as problem. So this is the session we have planned for especially problems. Okay. So the coming session, definitely we need to solve more problems for understanding concepts. Okay. So here, so determine the temperature at point P 4,3. The temperature node 1, 2, 3. So the 3 nodal triangular element 75 degrees Celsius, 90 degrees Celsius, and 60 degrees Celsius respectively. So here 1, 2, 3 points. So first 75, 90, and 60. And the coordinates are 2, 2, 7, 4, 3, 6. So I'm going to find out that. So the particular point temperature value. Okay. So definitely this is the scalar variable. I'm going to find out only the temperature in the particular point. So just I come very known formula. our temperature say function T of x comma y equal to N1 T1, N2 T2 and N3 T3. So here T1, T2, T3, all the temperatures are known value. Okay, so we can directly taken from our question. So definitely we want to find out N1, N2 and N3 value. So N1 we know determinant of A1 by A, N2 was determinant of A2 by A, N3 is determinant of A3 by A. Okay, so here I want to unknown is the A1 A value. Okay, so definitely we have a formula. So if you want to find out your area, the whole triangle area value, so I'm going to consider for that 1, 2, 3 nodal coordinate value, 1x1, y1, 1x2, y2, 1x3, y3. From that we can easily achieve your value as a area. Otherwise you can simply substitute your breadth and height value in half into BH formula. Definitely you will be get your triangular area. So whatever way you can follow, because this is the coordinate point. So this is the way for getting easiest way for getting your answer. Okay. So next I'm going to find out the A1, A2, A3. Okay, A1. If you have to consider the A1, so definitely you want to find out. Here I am going to take this is the 1. So 2, 3 is the x2, y2 and x3, y3. Here this is for the central point, x and y point. Okay. So from that you have substitute xy. Here x2, y2, x3, y3. So you may substitute the value. Finally, it is just I have taken the determinant. So finally we got the value A1 as somewhat area. Okay, so the same way I'm going to, this is the 2. So opposite value is the 1 and 3. Okay, so opposite value is the 1 and 3. Just you should follow that anti-clockwise direction. So 1 minute, anti-clockwise direction. For example, I have taken this is my triangle 1, 2, 3. So anti-clockwise direction. If you have to consider this one, so anti-clockwise direction 3 and 1. So x3, y3 and so x1, y1. This is for the so xy or centroid. I mean central point value. Okay, so this is the way just I have obtained my A2 value. Okay, this is the very simplest way for solving problem. Just to understand the concept for safe function. Definitely these all are very easy. So just we just I got A2 value. A3 is means 1 and 2. So just I have consider as the so 1 x1 y1 and x2 y2. This is the x and y point, the particular point. So you will be get the A3 value. Now you can substitute all the value in our safe function. N1 equal to determinant of A1 by determinant of A, N2 equal to determinant of A to A, determinant of A3 by A. We know all the value. You can substitute your N1, N2, N3. So just I have substituted N1, N2, 3 here. So in question we know the temperature as 75, 90, 60 degrees Celsius for the each nodal point. Just I have multiplied. Finally I got temperature. This is the 80 degree Celsius as the 4,3. Okay, just you can again you should remember the concept. So what is the interpolation function? Just we can find out the unknown value within the element, within the nodal. Okay, so this is the 4,3 within the element, within the node. I can temperature my temperature value by using our safe function or interpolation function. Okay, so this is the simplest problem. I mean I have taken only the 3 nodal. Just I have solved a very easy manner. If you have considered as the QST element, if you have considered as the LST element, the number of node will be increased. Okay, that time it will be difficult. Definitely we can solve the problem. Definitely we need to go for the computer to solve this problem. Okay, so that's why we are using our software ANSYS, Abacus, Hypermesh, Nastran. So definitely all of the software definitely give the more accurate result. But the mathematical concept behind of is the this is the way we have obtained the safe function. Okay, so next the second thing, this is that way second sum. So nodal coordinate of triangular element at the internal point p of x. I mean I'm going to consider as the p of x coordinate is 3.3 and n1 is the 0.3. Determine n2, n3 and the y coordinate p. Okay, so you can consider for example the diagram. Okay, I will draw. So here this is the simple diagram. So I'm going to take it as my triangular element. So this is the first, second, third point. So this is a p of x coordinate is 3.3. They have given some value as a x. Here the central point p, they given x value as 3.3 and so the y value is not given. So definitely we want to find out y coordinate value. So and they given n1 value. Okay, so we need to find out n2, n3 value. Okay, this is the simplest product from the shape function, and just we come across so many formulas. That formula derivation is very helpful for solving this problem. Okay, so first nodal, second nodal, third nodal. So center point x, y, x value given, we want to find out y. So n1 given, we want to find out n2 and n3 value. Okay, this is the problem. So again, you should remember your shape function. Here our area formula. So here I can write it as, if I'm going to take it as the a1, xy 2 and 3. Okay, xy, x2, y2, x3, y3. So I know that x value 3.3. I don't know that y value. Just I have take it determinant. So just I'm going to keep it as y as the constant. So a1 we will be get instead just some terms of y. Okay. So again I'm going to rewrite the a1 into the simplest form. Okay. So a1 as the simplest form in the next slide. So area we can find out the simple way. So because we know the three nodal point value. Okay, x1, y1, x2, y2, x3, y3. Just I explain the concept. Okay, so you don't want to worry about that problem and all. So we know that all three nodal. I mean, if you take the triangular, first node, second node, three node values. If you substitute it, you may get your area value. Okay, so here so this is the, I'm going to rewrite the a1. So I'm going to add 28.75, 8.25. So divided by 2, I'm going to divide by 2 in that both the constant. So finally 10.25 minus 1.25, this is by a1 value. So here one special thing in question we have a n1 value. Okay, so n1 means already we know. So n1 equal to, so a1 by a1 by a. So a1 we have a in terms of y. Okay, a1 means in terms of y. So I can write it as we have found area value. From that we can find out your y value. Okay, if you consider this is your triangular element. So in question we have a x. Now I have found y from n1 and my shape function a1 formula and my shape function formula n1 equal to. Okay, so determinant of a1 by a. This is the form. From that three formula, just we have obtained our y value. So again, so in question we need to find out n2 and n3. Okay, in question already they asked so n2 and n3. So now I am going to find out n2, n3. Just you may get from reverse. n2 equal to, you know, that formula a2 by a, n3 equal to a3 by a. We know that a value, we don't know about a2 and a3 value. So definitely we want to find out a2 and a3 value. Okay, so now I'm going to find out a2 value. This is the concept second, and I'm going to substitute 3 and 1. If you take it this the third node, you want to consider the 1 and 2. Okay, this is the simplest thing you should remember. So from that I can obtain my a2 and a3 value. I can simply substitute my equation. Sorry for this scribbling. Just you can understand. A2 equal to 1 by 2. 1 xy x3 y3 x1 y1. So we know that we know all the values. So from that definitely we can obtain a2 value and a3 value. So n1 already given. So n2 we have a formula a to a and a3 by a. Finally we got 0.1 and 0.6. Okay. So we know the characteristics of shape function. The sum of shape function value will be 1. Okay, the one nodal point will be get the 1, other nodal point will be get the 0. Okay, so like that. So here we can check our problem with that our shape function characteristic. So n1 equal to 0.3, so n2 equal to 0.1, n3 equal to 0.6. Definitely we will get, so 1 as our shape function value. So definitely it may be satisfy the characteristics of shape function. Okay, this is the simplest second type problem in the scalar variable. Okay, so next I'm going to talk about that third type problem, whether if temperature region, if in question they given temperature region, how to find out the coordinate value using the shape function. Okay, so this is the way I'm going to solve this problem. So read the question. Find the temperature at point P of 1,1.5 inside the triangular element, which the nodal temperature given as T1 equal to 40, 34, 46. 40, 34, 46. Also determine location of the 42 degrees Celsius. This is the third type of problem for the scalar variable. one-dimensional triangular element. Okay, so here I want to find out the location of the 42 degrees Celsius temperature process. Okay, 42 degrees Celsius contour line for the triangular element. Just you can watch this concept. So here this is for the 40 degrees Celsius. Okay, this is the 40 degree. This is for the 34 degree. This is for the 46 degree. So 42 degree will become between 40 to 46. So definitely our point may become this side. I can take it as this edge length 40, 46, 42 definitely between 40 and 46. There is no possible for coming between 34 and 40 because of this is the 42. So here there is no possible way. And also I am going to take it as the 34, 46. Definitely the 42 may be obtained. So in between, so second point will be obtained. So definitely we want to find out XA, YA value and the XB, YB value. Okay. So just definitely you can understand already we have proved the shape function. So again I'm going to use for the geometrical rule for obtaining the solution. Okay. Right. Okay. So here I'm going to just we have a x1, y1, x2, y2, x3, y3 value. Definitely we can find out our area values. Okay, area is the total value. A1 means that I'm going to split up into the three triangular. This is also I'm going to take it as the area coordinate method if you consider this like. So 1 means this is for the 2 and 3. 2 means 3 and 1. 3 means 1 and 2. Like that I'm going to split up. Okay. So next simplest way I can find out my A value and A1 value and A2 value. Okay. So next, finally, I got 3 area and that assaulted, area, the total triangle area. So we know that shape function 1 into n3. So finally, we have obtained some value A1 by A and A2 by A and A3 by A. This is the 3 value. Again, you can check the characteristic shape function n1 plus n2 plus n3. This is your value. Okay. So finally, definitely we can find out that central point temperature 1, 1.5. We know that n1 into n3 value, temperature 3 nodal temperature value. Definitely we can just say we got 41.5 degrees Celsius. This is for the first type of problem. In this problem, I want to go through the center. If 40, they given 42 degrees Celsius. Okay, we want to find out the determined location. Okay, so I'm going to use my geometrical rule formula. Just I found 1 3 into 2 3 is the possible way for obtaining 42. 1 3 and this is for the 2 3. Here 1 2 is not possible, so leave it that portion. Okay. So next this is the geometrical rule. Okay. So here I'm going to again you remember you can write it as I'm going to take it as the anti-clockwise direction. If you consider xb yb, xb minus x2 divided by x3 minus x2 is equal to t minus t2 divided by t3 minus t2. Like that you can write it your geometrical rule. Okay. So here t2, t3, t2 and t3 values are known value. Okay. T value means that is for the crosses, the temperature region. Here they given 42 degrees Celsius contour line. This is the contour line. Okay. So this is the 42 degrees Celsius. Okay. Just I have substituted 42 degrees Celsius. So here x2, x3 values are known value. Okay, x2 and x3 values are known value. So from that definitely we can find out our xb value. Okay, this is the xb value. I'm going to apply the same rule. Okay, so here I want to find out the yb. yb minus y2 divided by y3 minus y2 is equal to t minus t2 divided by t3 minus t2. Okay, very simplest thing. Okay, so from that everything we know t2, t3, y2, y3. So temperature region 42. Definitely we can get your YB unknown value. Okay, so so for that contour line, just we have find out our location as XB and YB. Just I have found XB and YB. Okay, so everything the fundamental for the shape function. Okay, so next thing I want to find out my XA and XA and YA. Okay, so this is my anti-clockwise direction. So I'm going to find out XA, YA value. So XA minus x3 divided by x1 minus x3 is equal to t minus t3 divided by t1 minus t3. So like that we can find out our temperature value. Okay. So now I have found XA, YA value and XA, and from that everything known value. I hope you can understand very clear. So temperature as the contour line. So XA, we can find out XA. Here all the values are known value, temperature is in everything. So OA is the unknown value. So we can find out your OA value. Okay. So like that you can easily solve your problems. Okay. So next I'm going to solve problem with the rectangular element. Okay. Rectangular element, we have a 4 nodal, because of I'm going to consider as the n1, n2, n3, n4 as our safe function. We have achieved this formula from that derivation, 1 minus x by b, 1 minus y by h. So x by b 1 minus. So you can we can also try the safe function with a different model. So from the same concept, the same boundary condition, we will be get some trial. N1, n2, n3, n4 as the safe function. Definitely from the safe function we can find out our intermediate values. Okay, we can try safe function as our own way. Okay, so this is the 4 nodal rectangular element coordinates are. Here I am going to consider this is the rectangular element. Okay, just you can, I hope you can assume this one. So 1 and 2 and 3 and 4. So the 4 nodal n1, n2, n3, n4. Okay, so here the temperatures are T1, T2, T3, T4, T1, T2, T3, T4, and this is the central point temperature 2,1. Okay, so 2,1 is that. So here if I have to consider, this is the 2,1 point. Okay, so now I'm going to substitute my value. B is the breadth value, everything we know from. If you have written this is the 0, 0, 3, 0. If you have written 3, 0, third point is as 3, 2, and the fourth point one is the 0, 2. From that you can obtain. So here this is the breadth 3. So here 2 means this is the height 2. So instead of breadth and height, you can substitute your 3 and 2 value. So x and y means this is our particular point. Okay, this is the 2, 1. So 2, 1, this is my particular point. So now we got all the values. So from that definitely we can find out our n1, n2, n3 and n4. Okay, so next I'm going to substitute my safe function. So we know that safe function x2, y2 means that is the 2 and 1. Okay, so finally t of x, y equal to rectangular element. I'm going to consider as n1 t1, n2 t2, and n3 t3 and n4 t4. Okay, from that, so finally we will be get the safe function. We know all the values n1, n2, n3, n4. So temperature, so we can find out your temperature, temperature for the particular point. Okay, again I want to remember if it is in rectangular element, we got that question as a contour line. For I'm going to take it as for a 4 nodal rectangular element, determine the temperature at point 7,4. So 7,4 means it may be that central point. Okay, this may be the central point. So temperatures are 42, 54, 56, 46. So here this is for the 42, 54. I'm going to take it as 56. I'm going to take it as a 46. Also determine point at the 50 degrees Celsius. So 50 degrees Celsius where will become. So here this is that 42 to 54, definitely 1 point will become. So 54 to 56, not 50. 46 to 56, definitely 50 will be achieved. So again 46 to 42, 51 come. So so our intermediate point may become here and there. Okay, so like that we can easily understand our problems. Okay, so the same rule I'm going to use, but that safe function will be very different. Definitely we know the shape function defines the shape of the element. Okay, so definitely the shape of the element will be vary. Definitely shape function will be vary. Okay, so this is my central point. So this is my region as 50 degrees Celsius. So finally, definitely the 2 point will be occur. One is the XPYP, second one is the XA OA. Okay, second one is the XA and the OA value. So finally, I'm going to substitute my value. I don't want to explain the problem, just I will give some idea. Definitely you may understand the problem concept. So we know that all P1, P2, P3, P4 point value. Okay, so definitely you may understand what is the B and H, which one is the breadth and which one is the height. For example, if you taken as the x1 first coordinate, second coordinate value, you may get the B value. So second, this is for the height value, this is for the H value. So B, H value we know. X and Y already given in the question 7,4. So from that definitely we may get the temperature for the particular point 7,4. Okay, so next I want to find out the second thing, that is for contour region. You can use your safe function. So BH breadth and height value we know. X and Y value is the unknown value. I mean that particular point value. So N1, N2, N3, 4. So our state function equal to T of X comma equal to N1, N2, 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 N3, N3, N4, N4, T4. So from that definitely we make achieve your temperature value. Now I want to find out the contour region location value. So definitely we need to use our geometrical rule. Okay. So again, I'm going. This is for the rectangle anti-clockwise direction. If I am going to take it as that XA as that my point, XA minus X1 divided by X2 minus X1, T minus known value. This is a field variable. Don't consider temperature as that constant. For it depends upon problem. Any scalar quantity, maybe that it may come whatever the point. Okay. So here I'm going to take it as the temperature. Okay. So T minus T1 divided by T2 minus T1, and also the same concept I'm going to apply for the YA minus Y1 divided by so Y2 minus Y1, and so T minus T1 divided by T2 minus T1. Here we know all the values. From that definitely we can find out our XA YA value. The same concept I'm going to apply for the XB and YB. Okay, so XB YB I'm going to apply for that. Here we know that anti-clockwise direction. So we want to consider XP minus X3 divided by X4 minus X3 equal to T minus T3 divided by T4 minus T3. Like that you should consider your geometrical rule. This is the unknown value. You can find out XP and YB value from here. Okay. So next next I'm going to talk about one more thing. So far we have discussed, we have derived one shape function for one-dimensional triangular element, and we have derived shape function for one-dimensional rectangular element. Two-dimensional rectangular element, and so we have solved three types of problem. Whether they may given that location, we have to find out the temperature. Otherwise, they may give a contour line. We can find out the location using the geometrical rule under the shape function interpolation function. So from we have used A1, A2, A3 and A formula, and N1, N2, N3 formula. Okay. For example, if you consider the one-dimensional element, okay, and one-dimensional element, how we can achieve accuracy? Everybody know that basic fundamental thing. If I'm going to consider as this is my one dimension, just I'm talking about one dimensional, don't confuse 1D and 2D. Okay. If you want to achieve your accuracy, so just we have to divide into number of elements. Technically we can say missing in software point of view, in analytical mathematical thing, discretization, art of subdividing number of elements into sub elements. Is it? So we want to we have to split up into if I consider the linear, I'm going to consider the 1 and 2. So shape function will be attain something. If I'm going to consider 1 and 2, 3, and if I consider the third node in the center of your one-dimensional element, so it maybe comes under the category for quadratic. Okay, so quadratic also we can solve shape function in mathematical way. If it is fourth one, if you consider fourth one, it may be quartic, fifth one quintic. If we increase the number of element, definitely we can solve shape function by conventionally. Definitely we want to go for with the software. Okay, so like that I'm going to explain for two-dimensional element. Okay, like that I'm going to explain for our two-dimensional element. Okay, so two-dimensional element, how we can achieve our accuracy. Okay, so that's why we are going to discuss about CST and the LST and the QST element. Okay, so further lecture we will discuss very deep manner how to achieve shape function in the constant strain triangular element. LST is very difficult. Definitely we can I think we can solve shape function for CST element. LST QSTs are very difficult. Okay, so for achieving our getting more accuracy, what is meant by CST? So CST means that is for the constant strain triangular element. Okay, so next one is the next one is the LST element, linear strain triangular element, and the quadrilateral strain triangular element. What is the difference between CST, LST and the QST? I will give some a few more ideas. Okay, so here I am going to consider the constant strain triangular element. Definitely this is for the triangular element. Okay, so whenever next scalar variable, nothing. I have discussed almost all those things behind of the scalar. Definitely next we want to enter the vector. So I'm going to consider as the triangular element. So each node we have a 2 degree of freedom because V1 and X and Y, X and Y, X and Y. I have considered all those things because of here after we are going to discuss about the vector, we want to find out force as well as the displacement. Definitely it has both the magnitude and the direction. Okay, so I'm going to consider the 2 degree of freedom in each element. So definitely you can easily understand we have a 3 node. Is it 1, 2, 3 node? So degree of freedom, each node 2 degree of freedom, definitely 6 more degree of freedom. Okay, so definitely we will solve shape function for the coming lecture. It is very easy understand. We can easily understand the mathematical way. Okay, so if I'm going to consider linear strain triangular element, so just you can consider you can simply define a node as 6, first node, second node, third node. So in between we have an additional node, 4th node, 5th node and 6th node. So far we have a 6th node and we have a 12 degree of freedom. We have a 12 degree of freedom. So definitely you can understand now the element will be increased. I mean number of node will be increased. Definitely we will be getting more accuracy. Definitely we can understand the behavior of inside the element. Okay. So whenever I discuss about the CST, I can say simply inside the element the strain may be constant. Okay, inside the element so strain may be constant because of I am going to consider only the nodal 3 nodal. We don't want to discuss we can't discuss about the inside. So inside element definitely that strain value will be equal. So definitely it may be it not may be the more accuracy. So now we have taken the inside as one of the nodal. Definitely we will be get more accuracy than your CST element. Okay, a QST definitely we can understand the behavior inside the element. We can find out your stresses each element. Okay, so that's why we are using LST element for the analysis. Okay, so if you have to consider for the here is a 6. So definitely the each nodal we have a 2 degree of freedom. So finally we will be achieve the 12 degree of freedom. So next thing I'm going to consider quadrilateral strain triangular element. This is the very simple thing. Here first node, second node, third node CST. If we consider the central node 60 degree of freedom is there. I mean LST, QST we have a 2 nodal inside the element 1, 2 and 3. Here 4. I'm going to 5, 6, 7, 8, 9 and we have one central node. Okay, inside the element we have considered for the one center node. Okay, so this is we have a 10 node. We have a 10 node. So 10 2s are 20. Finally we got so 20 degree of freedom. Definitely we can solve the shape function for this element because of it is very tedious. Okay, so in software we can make it as a lakhs of lakh. I mean we can create one node in the software. Okay, so with this I'm going to conclude my lecture. So this is the turn for you. So you can ask some of the questions. Definitely I will answer. I will within 1 or 2 minutes. I will give recall everything. So almost in FEA point of view, almost we have covered in the 3rd unit scalar variable problem, and we have touched the 4th unit vector variable. This is the very fundamental things behind of it. So whenever discuss about the vector variable, we want to express from the continuation of shape function. We want to discuss what is the stiffness matrix, what is from the strain displacement matrix, what is the stress strain relationship matrix. So how material property comes to the picture. So how the coordinate is integrated in that B strain displacement matrix. Everything we will discuss in the vector variable problem. Okay. So from that we have to consider vector. Just to understand what is a scalar vector, we can find out all the variable in the vector quantity. Okay. So first
Today afternoon session, before 2:50 p.m. Okay.
Okay, participants don't miss any hands-on training in this series. Whatever we studied, definitely we can visualize through software. It may be that better understanding how the shape function working. In ANSYS APDL, definitely we can get results in each and nodal point. ANSYS is very beautiful for getting results. ANSYS workbench, it may be very familiar and easy, but compared to APDL, the results are getting somewhat difficult. Okay, so just to follow hands-on session, and also in our RIT Mechanic Center YouTube channel, we have updated so many ANSYS trial things. Definitely, you can replace that. You may get some more ideas. Thank you very much.